So first thing that we'll probably notice when we look up here is that we have this word polynomials. And when we talk about adding and subtracting polynomials, we sort of open the door for this huge chunk of information that kind of just turns into vocab. That vocab piece is not where I want to spend the majority of our time. Okay, we're going to talk about it. You'll hear me use it enough that you'll start to pick up on it. But here are the things that I want you to understand. What does the prefix poly mean?
Multiple.
Many. Okay, so when we are talking about a polynomial, we are talking about multiples of the things that we've been seeing. Okay, everything that we've been seeing is just one thing plus one thing. So does anybody know what the prefix for one thing is?
Mono.
Mono. So a monomial is what we have been looking at. Okay, what's the prefix for two things?
Duo.
So trinomial is three things. Binomial is two things. Okay, so when we're talking about polynomials, we're talking about doing the same thing that we've been doing with adding, subtracting, multiplying, dividing, zero exponents, negative exponents, except now we're dealing with, instead of it being a monomial plus a monomial, right, one thing plus one thing, we're now talking about multiple things plus multiple things. Okay, the good news is that basically this is just one a little bit more complicated puzzle of combining like terms. So if we understand that Algebra 1-1 concept of combining like terms, we don't have a whole lot of new info that's being added. Okay, so maybe we have something like 4x squared plus 3x minus 9. And we want to add to that 2x squared minus 7x minus 2. I'm just pulling this back over so it doesn't, sometimes it will make the screen go blank. Okay, so in this situation, we would be adding something with three pieces, a trinomial plus a trinomial. Can we all agree that this top one has three pieces? Those three pieces are really called terms. Okay, so this is a term, this is a term, this is a term. Right? I don't need you to like completely have a vocabulary notebook. I just want you to understand when I say, oh, that's three terms. You're like, okay, yeah, I know what she's talking about. Okay, whether or not you recall that word right away is not the more important piece. Okay, so if we want to add these two things, we are going to add just like it was multi-digit addition, right, where we add straight down. And basically all we're going to do is three different problems of exactly what we already have been said to do. So when we add with exponents, what happens to the exponent? It stays the same. So I'm going to ignore all of this, and I'm going to go straight down.
6x.
4x squared plus 2x squared is
6x.
a 6x squared, because we already know how to do that. And class, here's the deal. My students know how to do this. My students have no problems doing this. My students don't add correctly. And that is where they miss the problems. So use the calculator if you need to use the calculator. Because if we go here, what does this say?
3x plus negative 7x.
There was a confident. Be boldly confident with your answer. Okay, 3x plus negative 7x is correct. Or it could say 3x minus 7x. Okay, you just have to make sure you're doing the correct math. So in your calculator, you can't type a variable, but in your calculator, you can type 3 plus negative 7. And what does that give us?
Negative 4.
And then just keep the label the same. Okay, then we'll go over here. And now we have negative 9 plus negative 2.
Negative 11. Negative.
Wait. Oh yeah.
That is our answer.
Crazy.
I mean, pretty straightforward, right?
Yeah.
And then my students are like, why are we even taking time doing this? This should take like 30 seconds, Mrs. McKinney. I got it. The reason why I get concerned when I do this all the time is because not only can my students not, I shouldn't say not, they make errors in their basic computation. Addition is fantastic. Subtraction is a hot mess, right? So let's say we have this problem. We're still gonna keep it pretty straightforward here. 3w to the third minus 7, that's a terrible 7, 7w squared plus 8w. And we're gonna subtract off a 2w to the third minus 5w squared minus 2w. Okay. You can decide to subtract. I'm not going to tell you that you can't subtract, because this is clearly a subtraction problem. I'm going to tell you in the nicest words that I possibly can that my students suck at it. It is awful. It is like terrible, train wreck, hot mess of a world that we all think we're subtracting perfectly, and they're like, what happened? I'm like, oh dear. So here is the solution. Don't subtract. Change subtraction to addition. Just like, oh, look, there's a lovely example of it. Just like when we taught or we looked at problems like 2 minus 3, we could add the opposite there. We can do the same thing here. And here's the easiest way that I tell my students to think about it. Think about changing this to addition and then writing your subtraction sign in all 3 places. So putting your subtraction sign here, putting your subtraction sign here, and putting your subtraction sign here. All right, I'm putting that subtraction sign in all 3 places.
That's complicated.
Okay, but hang on, because you won't really actually write it in all 3 places. Because 2 negatives make a positive. Right? So what we're really doing by putting that subtraction sign in all 3 places is changing the sign. Right? We're making it the opposite sign, because that is what it's called, adding the opposite. So this 2 was positive, so it becomes a negative. This 5 was negative, so it becomes a positive. The 2 was negative, so it becomes a right? And the reason why is because that subtraction is going to all 3 locations. It's a really simple, quick fix. And if you take the time to do it, I see like 98% better answers. Small fix, huge reward. Do it. Okay? So now when we add 3w to the third plus negative 2w to the third gives us what? 1w to the third. Do I have to have that 1 in front? No, so if you have it or if you don't have it, it's fine. Negative 7w squared plus 5w squared is what? Negative 2w squared.
Hold on.
Positive 10.
Breathe. Tell me where you're confused. Where something came from,
Why is there a positive in front of the negative 5?
So right here, right, I took this subtraction sign and I put it all the way through. Okay, so if I put that subtraction sign here, I'm going to change the sign of it. So if it was negative, what is it going to turn into?
Positive.
And if this was negative, it's going to turn into a. And if this was positive, it will be a. And so that's where those signs each came from.
So,
In those 3 places.
so if they were all negative, they'd be all positive.
Yes,
If it was a subtraction thing.
correct. It's only in a subtraction problem that you do it, and you only do it in whatever is the second one, the second polynomial. Okay, but then once we get it turned into addition, then our math is fine and then I don't see any problems. Okay? Are we okay there?
Yeah.
Fill out the rest of it. Unfortunately, our life isn't always that easy. It gets a little bit more complicated because sometimes they aren't nice and neatly written all stacked for us. I mean, stacked is fantastic. It's glorious when they're stacked. Life is nice and easy and friendly when they're stacked. But sometimes, unfortunately, we get this. Okay, and then I always have those couple students who go, well, Mrs. McKinney, well, can't I just write them stacked? Sure. However, they won't always be able to be turned into something that can be stacked. So we don't want to always rely on that. But if you can turn them into being stacked easily, by all means, go for it. Okay, when we're in this format, this is where we're really, truly just thinking about combining like terms. Now, once again, this is a subtraction problem. Subtraction is where we have the train wrecks. So what did I say we should turn subtraction into? Addition. And then we're going to change the sign of everything following it. Okay, so the 5y squared is going to become negative. The 6y is going to become negative because it's already positive, and the negative 2 is going to become positive. Okay, and then we are going to start combining like terms. Again, we have another piece we have to add here. Polynomials means many terms. Now, I'm not going to torture you and do 100 terms plus 100 terms. Okay, yes?
You only do the right side?
Only what follows, what comes after the subtraction sign. Okay? Okay, but if, that's a big if, we're not going to. If we had to add 100 terms plus 100 terms, and we didn't agree upon the way that we wanted to put our answer, could we agree that it is going to be a mess? Right, so if I have one number first, but Chloe has a different number first, and Haley has a different number first, and Sarah has a different number first, I mean, there's like a bajillion different options we could write the actual answer in. So as mathematicians, we have said there's going to be a specific format that we write our answer in. And that specific format says we want to write from the largest exponent to the smallest exponent. Okay, so when we look up here, we want to start with the largest exponent no matter where it is located. So what's the largest exponent that we see up here?
4y squared.
4y squared. Okay, and we will then ask ourselves, is there anything else that has a square? Yeah. Okay, so what is 4y squared plus a negative 5y squared? Right? You could have the 1. You don't have to have the 1. It's fine either way.
I thought if it was negative, you had to have the 1.
Okay, so we've taken care of these two. We've used them. What's the next largest exponent that we see?
Y. 2y.
Okay, so anything that will go with the 2y.
6 negatives.
Right, the negative 6y. Okay, so what is 2y plus a negative 6y?
Negative 4y.
Negative 4y. Okay, so we've taken care of these two. And then we have a a negative 7 plus a 2? So what is negative 7 plus a 2?
Negative 5.
Negative 5. Right, we're really just pulling like terms and combining them?
Is that the answer?
That's our final answer. We can't do anything else with it. It's my students want to solve something, okay, but this doesn't have an equal sign. There's nothing to solve. That is just our answer. At this point, all we are doing is simplifying.
Thank you.
Bless you. 3x minus 5x to the 4th plus 2 minus 7x squared. That's all going to go in parentheses. And then we're going to subtract off 4x squared plus 8 minus 3x to the 3rd. This one is clearly very different than what we've looked at because not only do they have a different number of terms, they're not in all a nice, neat matching order, right? So we have to do sort of more work. But if we stick to that idea of just picking that largest exponent first and then combining like terms as we go, they really don't get any more difficult no matter how long they are. They just, again, that same thing, they just take more time. Right? So if we look at this problem, the entire problem, what is the first thing that we notice that we should probably do something with?
Change the sign.
Change the sign. It's subtraction. Because it is subtraction, we should change the sign. So we will change the subtraction to addition. The positive 4x squared will become negative. The 8 will become
Negative.
the 3 will become positive.
You don't have to do that.
You don't have to do that, okay? But I'll show you in just one moment why it's really concerning and turns into a bit of a train wreck. What's the largest exponent that we see up here?
4.
X to the 4. Anything that we can combine with it?
No.
Nope, so we just write it down.
It's a negative though.
It's a negative, so negative 5x to the 4th.
But why is that the largest one?
Because this has an, I'm just looking right here at the exponent. I'm not looking at the coefficient, just the exponent. Okay? What's the next largest exponent that we see?
7 squared.
Right here. And here is why adding the opposite is really important. If we don't go through and change the sign, most of my students will write this down as a negative 3x to the 3rd. Because there's nothing to combine it with, so they write down what they see. But this would really be a 0x to the 3rd minus a negative 3x to the 3rd. And so we have to make sure we get this sign correct as a positive 3x to the 3rd.
But you just lost me.
Okay, so if you're choosing to not change the sign, I mean, are you okay with this being a positive because I added the opposite?
Well, yeah, but like, what if you just keep it as a negative?
I mean, that would be wrong. So if you're keeping the subtraction, you would have to consider that in this polynomial right here, there are no x to the 3rds.
Uh-huh.
And I would be subtracting from it negative 3x to the 3rd,
Okay.
which is a positive 3x to the 3rd.
All right.
That's where things start to go dangerously wrong. I'm acting like this is life or death here. It's not. What's the next largest exponent that we see?
That's squared.
squared. Anything we, oh, I need a new color. Anything we can combine with that?
Negative 4x squared.
Okay, so a negative 7x squared and a negative 4x squared will give us what?
3x squared. No. Never mind.
If you have to, put in your calculator, negative 7 plus negative 4,
Negative 4.
negative 11. Okay, class, and sometimes, I joke with my family knows this story, I tell it to students often, but my husband's brain functions like a computer hard drive, and it finds information really fast. I don't know, but my brain functions like a little old man, so I kind of see the guy from Up, you know, like walking around, and he's like trying to find, like dig through filing cabinets, I don't know, and like when you're trying to dig through a filing cabinet and find information about exponents and polynomials, but then also like reach to another filing cabinet that deals with adding and subtracting integers, sometimes it's really hard for your brain to find both. Okay, some people are very good at it. I am not very good at it. So sometimes you just need to let your calculator do the work with the actual integer operations so that your little old man in your head can be digging in the filing cabinet looking for stuff that deals with polynomials. There is nothing wrong with that. I will not judge you for that, especially when you are starting a new topic. Just put in your calculator, negative 7 plus negative 4 equals. Okay, that's my negative 11. I know I'm putting an x squared, cross that off, move on. Okay, it takes a little bit of that strain off your old man. What's his name? I can't, it's not Russell, that's the boy.
Fredrickson.
Oh yeah, Mr. Fredrickson.
Russell's the little.
Yeah, Russell's the kid. I mean, I'm a pretty good Disney one. I just, my little old man couldn't dig in the filing cabinet fast enough. Okay, what else do we have next? What's our next largest
3x.
exponent? 3x, anything that goes with it?
No.
Nope, so we'll have a plus 3x.
Oh my god.
Huh?
Something about big heads.
Last.
Plus 10.
Plus 10.
Not plus 10.
What?
This is a negative 8.
Oh.
Plus.
Minus 6.
Wait, yeah.
Yes, Bailey?
So, since we have like the negative 5x to the fourth and the 3x that don't have anything with it, couldn't we just write those first and then write the rest? Or would it be?
No, because if you're just writing down the ones that don't have anything with it first, you're not going to be in standard form. You have to have largest exponent of 4, 3, 2, right, decreasing.
Okay.
They have to be in that order. That's our standard form. Okay?
Big answer.
Yeah. And that is the thing. They do start to get very lengthy. They're not difficult. They're lengthy. That is the common theme as we go throughout all of our exponents and polynomials. They can just get long. They can be time consuming. Questions on that?
I feel like that cat picture is staring at me. It's really weird.